Hi! You work with chemistry. Maybe you study chemistry and you wonder if programming is useful at this point. I would say yes. In this video I show you how with simple Python code you can do a lot for stoichiometry calculation, something that sooner or later all students have to face. So please follow me and let's dive in the code. Once upon a time, people working with chemistry were writing formulas just on papers, and later on they were using spreadsheets and sharing by email. Today there are more efficient ways. Here you are on GitHub, very good place for sharing, and you can use Jupyter notebooks. See, you can open this in Colab, you don't need to install any software. Voila. Of course, I'm logged in with my user. It's enough to have a user on Colabs, and you can simply run it. That's it. While this is running, we can go through the code. So, first of all, good practice to import RDKit. This is a library taught for chemistry, bioinformatics. It's about molecules. You don't need to draw molecules anymore. When you have this installed, it's enough to give the code called SMILE. Say that I change the code. That's it. If I want to display it, I display it. I have one more bond. And same here. That's it. No need to draw anymore. Everything is taken care. Same for the isocyanate. This is a triol, this is isocyanate. Using RDKit, we have molecular descriptors. There is much more than molecular weight, but for stoichiometry, that's what we need. So we just work it out using the function built in. That's it. Molecular weight of our triol and molecular weight of our isocyanate. This is clearer for sure than having just numbers on a spreadsheet. And we can calculate the equivalent weights. Very easy. Just matter of dividing the molecular weight by the number of reactive sites, and so on. This is the OH value. This is something that for people who work with polyurethane is a recurring value, and is based on the titration that is normally done with potassium hydroxide. Voila, that's the OH value. Most of the time you get a polyol, so this arriving with OH value. That's what it means. Clearly stated, easy to calculate. Percentage of OH, if you want. I calculate this for you. Voila. And I calculate back the molecular weight from this, but that's simply academic exercise. You have it already. And then simply you can calculate the reactants. That's the isocyanate index, that's something more. You don't exactly need for stoichiometry. Weight of the polyol, how many grams you add of component A, how much do you need of component B. Easy. Everything is here, easy to check, and the formulas are giving directly the results. So, I hope you like this, and if you want to add more, for example, if you are really doing polyurethane chemistry instead of a simple demonstration, you may want to not have a little molecule but a proper polymer here, proper polyol. You need to add the chain extender for phase separation. That's polyurethane chemistry. We don't get much into that, but feel free to search online for this. And if you want to change the structure, for example, you want to add TDI instead of MDI, okay, you just change a bit the smile here, this molecular structure, everything will be recalculated. This is open source, so please feel free to modify for your need. I hope you liked it, and if you did, subscribe, and to the next.